Hi, welcome to Debug School. This time we're going to talk about taking small steps, also known as incrementalism. When we write programs, we have a tendency to write it from start to finish, sort of the same way that we might write an essay or an email. But then when you finish typing, that's when you actually have to run the code. And that's the place where you have the potential to run into trouble. You might get an error, and then when you try to fix that error, you might get another error, a different one this time. And sometimes it might not be an error per se, but it could just be a really weird behavior that you are seeing from your code. And that's actually even worse. Basically, you're going to have to go back and track down and fix all the bugs that are created by mistakes you made earlier while you were typing up that essay of a program. And this process of doing this can sometimes be time-consuming, or worse, it can be demoralizing. Luckily, there's a different way of going about it. You don't have to write a program in a top-down fashion. You can take a much more incremental approach. And I'm calling it incrementalism. And the way that incrementalism works is that when you write a program, you write it in a series of small steps. And after each of those steps, you run the program in some meaningful way in order to test that it actually works the way you expect it to work. And if it doesn't, you're going to fix it before moving on to the next step, and then rinse and repeat. That is basically incrementalism in a nutshell. Now, let me demonstrate. I have this CSV file with some people's names in it, and the task that's in front of me is to read in these names and sort the names by first name first, and then print each name on a line, first name and then last name. I'm going to use Node.js to write this program, but please don't get hung up on the programming language that I'm using or even my coding style. The first thing I need to do is to read in the contents of the file, and in order to do that, I'm going to need to require the file system module. Even at this point, I'm going to run the program really quick to verify that I have done this correctly. I'm going to run it using the node command, and when I run it, I get no output. Now, if I were to require a module that doesn't exist, or if I made a syntax error, then I would see an error on the screen when I run it, but I didn't. And that's good. That tells me that so far I'm on the right track. Now I'm going to get the contents of the file by calling the readFileSync method. And again, I'm going to run this to make sure I did this correctly. Oops, I got an error. That probably means I made a mistake somewhere. Can you tell where the mistake is? I feel like Dora the Explorer. Now, first thing, let's read the error message. So the error message says, error, ENOENT, no such file or directory peoples.csv. So it's trying to tell me that it can't find this file. Why? Oh, okay, I see why. My file is actually called people.csv, not peoples.csv. Peoples, that's not even proper grammar, right? So let's fix that and then run it again. And now I get no output. So that means, once again, we're on the right track. Let me clear that terminal so I don't have to look at that error again. Now, I want to verify that it's actually reading the contents of the file. So to do that, I'm going to print out the contents variable using console.log. I'm going to run this, and okay, that looks a little weird. Oh, okay, I see. So this is a buffer object, which is a buffer of binary data. But that doesn't help me because it's difficult to work with binary data. What I want is a string, which will be much easier to manipulate. So I'm going to convert the buffer to a string using the toString method. Now let's see what happens. Much better. That's exactly the content of the file. Now I'm going to split this content into lines. Let me run that and see that there are no errors. Okay. Let's print the lines and verify that they're correct. Okay, that looks good. This is an array, and each element of the array is a line in our file. Now I want to loop through each line using arrays for each method, but I'm not going to put anything in the loop body just yet. I'm going to verify it and see that there are no errors. Now in the loop body, I'm just going to print out each line. Again, run that to see that it worked. Next, I'm going to split each line on the comma so that I can separate the last name and the first name. Let me run that, and oops. Okay, so object Smith, comma, John has no method spree. Okay, so evidently I have misspelled split. So let me fix that and try again. Okay. Now let me print the names to see that the split actually worked. Okay, that looks good. We have the last and then first name of each individual inside of a 2-element array. And now I can form each person's full name based on that. So full name is the first name plus a space plus the last name. Run that and no error. Now let's try to print out the full name. Oops, I misspelled full name. So let me fix that and try again. Okay, well actually that still doesn't look right because I've simply printed the first name twice. And looking at this statement here, it looks like I used names subscript 1 both times, which would explain it. So I think I simply have to change the second one to names subscript 0. Let's see if that fixes it. Good. Now I want to sort these names, and to do that I'll use the arrays sort method. But in order to do that, I'm going to need an array that contains all the names. So let me make an array. Let me run that. Oops, I have a syntax error. So looking closely at this line, I see that I forgot an equal sign there. So let me fix that really quick. Okay. Now, inside the body of the loop, I'm going to push each full name into the array. And I'll verify that. Okay, no errors. Now, I want to make sure that the full names array has actually collected all of the names. So I'll print it out to verify that. That looks good to me, but they're not sorted. So now, let's actually sort the array. And that looks sorted to me alphabetically. And the last thing we have to do is just to print the names out one on a line. So to do that, I'll just use the arrays join method in order to insert a new line character in between each of the names, and then just print the whole thing out all together. So let's see if that worked. Oh, that doesn't look right. It looks like all the names are jammed together now. Oh, okay, this should be /n, not just n. So that's how you write a new line character. So let me fix that. And that's much better now. So that looks good. We have everyone's name here, alphabetized, and printed out one on a line. So I guess we are done here. So you just saw the incrementalism technique in action. And this technique is going to allow you to bounce back from mistakes very quickly. And for that reason, you are going to have a much more smooth and enjoyable experience while you're programming. Now, why does this technique work so well? Well, if you're taking small steps when you're programming, when you make a mistake, you're going to find out almost immediately. And early bug detection is the key to being able to fix bugs very easily. And experienced developers know this. Why is this? The first reason is you still have the understanding of how the code works fresh in your memory. And the second reason is that most of the time, the mistake that caused the bug in question lies in the thing that you touched last. And so, if you take small steps, you're going to have a much smaller amount of code to sift through in search of that mistake. And I'm going to demonstrate this for you further by going back to the beginning of my coding session. And I'm going to color any new and untested code in orange. I'm going to color code that's been tested and works well and behaves expectedly. I'm going to color those green. And I'm going to color any code that's been tested but works unexpectedly. I'm going to color those red. So we're going to start at the beginning. I write the first line, and it's orange. And then when I run it, it turns green. Then I type the second line, which also starts out orange. When I run it this time, though, it turns red because I encountered an error. When I revise the second line, it goes orange again. This time, when I run it, it goes green. Now, I'm going to let it play out to the end. And what I want you to notice is how little orange code I will have on the screen at any one time. Most of the time, we'll have no more than one line of orange. When something goes wrong, those orange lines will turn red. And I'm not so scared at that point because now I only have to look closely at those few red lines in order to find the mistake. In the demo, I took the small steps concept to the extreme, and I literally changed only one line of code in each step. In other words, I used a very small step size. And you might see that and be wondering if doing this might be a little bit too tedious, because you have to write extra print statements only for verification purposes, and later on you're going to throw them away anyway. And plus, having to test the code after each step also adds up over time. That is true. The more steps you take, the more overhead there is. But the justification of this overhead is that getting stuck is a really costly thing, because difficult bugs can take an order of magnitude more time than easy bugs. And if taking a lot of little steps helps you avoid even just one difficult bug, you could get back all the time lost from that added overhead. Now, you don't have to take smallness to the extreme to the degree that I did in the demo. You can experiment on your own and adjust the step size to your liking. So here's a simple heuristic that you can use to find your optimal step size. If you get stuck on debugging, then your step size is too big. So when this happens, you want to back out to the last known good state. The last known good state is the last time that your program ran perfectly, where everything behaved just the way you expected. And in our demo, that corresponds to whenever the entire program was highlighted green. Once you've backed out to the last known good state, you can just start over and try again using a smaller step size. The optimal step size is something that you'll find for yourself, and it will change depending on your skill level, how familiar with the programming environment, how well is your brain working for you that particular day, and there are definitely other factors too. So try out this technique. At first, it may seem a little unnatural for some of you. In order to get a good feel for it, you're gonna need some practice. So towards that end, I have homework assignments laid out for you. Please take the time to do this because this is really important to get the material to stick with you. I'm going to conclude here for this lesson, but I'll come back to this topic of incrementalism in later lessons concerning refactoring, working with legacy code, and more. So I'll see you soon.